Yeah, same.
Alright, well, we're recording, so right, should we go through it then? Especially for, let's simplify things.
Yeah,
Yeah. So we've got the situation where this moves in, doesn't it? And that kind of shortens this, but doesn't shorten the distance being P and Q move. The unknown distance is one that we're not really worried about, which is the hypotenuse. We're looking at the base of the triangle and the vertical, so the horizontal and the vertical. Okay. All right. So, talk us through it, people, then. If it says, write down scale factor of enlargement in the diagram, how do you do it? Greg?
So, since the diagram conveniently has is composed of squares,
Yeah.
it is an equally sized squares. It is an easy way to tell distance. So you can then tell that the distance from P to S is half the distance of P to B. And the distance of P to R is half the distance of P to Q. And since it's saying you're finding PBQ from PSR instead of PSR from PBQ, it's the lengths are all getting doubled. So the enlargement or the scale factor is 2.
Yeah. So just one thing to say that distance there, we basically compare it to that distance there, because we can count, that's 2, that's 4. Okay? This is 1, that's 2. Okay? So like you say, the scale factor is times 2. Now the one thing we then hopefully notice as we go further is that this distance, well, I don't know what that distance is. I can, however, tell that it has been doubled, but I don't know it. So I kind of try to avoid that one if I can. But yeah, so the scale factor is times by 2. So complete the table for enlarging the diagram, the triangle PSR. So if the scale factor is times 3, if length of PS is 4, the length of PB will be 12. It's as simple as that one times that. So 6 times what gives you 30? 5. Scale factor 70, something times 7 gives you 14. It is 2. Yeah.
Oh, because of the length of PS?
And this one, I'm glad you got these ones right, because obviously I've told you that this is all about similar triangles.
That lets you know that.
I'm just going to make a comment on one thing. One of you said in the exam, I tried to turn you away from that way of thinking, but you wrote it on your paper. But it does say in the beginning of the thing something about this investigation is about finding connection. Move. All triangles are right-angled and 1 unit. All right-angled. All of them.
Okay, thank you.
They're all right-angled. Second line of
Reading is really important.
paper.
Yes.
So show that x equals 10 when PB is 20. Well, we kind of are just looking for. Go on, Greg.
Actually, you can explain it.
Well, we know the ratio of PS to PB, okay, will be the same as RS to QB. Right. So if we know that PB is 20. Right, and we know that PS is 2, then we're going in the same ratio. So if RS is 1, the same ratio would be then to 10. Yeah.
These questions, I know there's only one grading, so the communication didn't matter, right? It was just the final answer? Or did the communication matter?
No, so in certain parts there is, if I were to mark this in the way that this paper would be marked for an IGCSE, there is an extra communication mark. Okay? And it would come at just one for the entire paper, and you would have to show communication in so many parts of the whole thing, or maybe just one or two parts. But because I'm marking it criterion based, like Kieran got lots of slightly incorrect answers, it didn't necessarily stop him from reaching the criterion, because I'm looking at what knowledge you are showing and how you communicate in the whole thing. Okay, so find the value of x when PB is 16. So 2 to 16, yeah, we're looking at that. 2 to 16, so it's going to be 1, 2, 8. We're showing this. Find an expression for x when PB is y.
So you would do PB is y.
Do you get the whole find an expression for x?
Yeah.
So what do I have to have when it says find an expression for x?
X on the screen.
Yeah, it needs to be x equals or something.
I know, yeah. You did,
Yeah.
Mom told me that, sorry.
So when it says find expression for x, we're having x equals, so it should not have an x in it. So then what I have here will be the expression.
Okay, yeah.
Yeah.
Oh,
The question A and B, like what made it easy for me is I just drew them out, and then I put the x where it would be like b to q, and then it just was like 2, 16, and then 1, and 2 times 2 is 16.
Yeah.
So 1 by x. And it was, like I didn't do it really much.
Yeah, no, it's fine. There are different ways to do it, however you want to do it. So in this case, it says PB is y. You're now looking for what was it you were doing. So find an expression for x. This is x. What do you do? So we've got 2, yeah?
So, y, and then
2 to y would be 1 to x. But we actually need an expression now, calculation. What do we do?
what x equals half y.
So half of y. So we'd write y over 2. Does everyone understand why we get that? Y over 4. Okay.
Oh wait, sorry, I got y over 2.
good, yeah, good. I didn't say anything because I thought he would mark me down, but yeah, I was reading the wrong question too. That's why I was super silent.
Why is it like that though? Because we've got the same thing, haven't we? We're talking about the ratios. The relationship between x and y is the same as the 1 and the 2. That's the other thing. Okay. So we can look at 1 to 2. We look at the ratios in different ways. So we've also got the ratio 1 to 2 and x to y is another way of writing it with our similar shapes. This is why I said do work on similar shapes. So we know that we take x, we multiply it by 2 and we get y, or we have y and we divide it by 2 and we get x. Yeah? So we've got y divided by 2. So then for this triangle, find an expression. Well, the same thing. We've got 1 to 4, x to y, so y over 4, yeah.
So for C, it was y over 2, and for,
Yeah.
for 3A, it would be y over 4.
Yeah. Alright, does that make sense for you all? And now we start, in this diagram, here's at A, find the value of y. We're happy with these? Are we kind of now at a stage where you're kind of happy with what we've been doing? Okay?
Yes.
Alright, so then we get to the stage where we move it. Right? Find the value of z. What did you do? Yeah.
Wait, which
Okay.
question is this?
Well, I just used the same like formula we've been using.
Yeah.
And so x equals z divided by 2, like the little, like,
So x up here.
yes.
So we've actually got 6 equals
And then I changed it to 6 equals
z divided by 2.
z divided by 2, and then
So z equals 12. So you've used what you've done before. Make sense?
Yeah.
Yeah? That's the whole point of these papers, use what you've done before. Using your answers for part A and B, work out the value of AP. So this is where they add the next bit in.
just the answer for the first one, the back information.
Yeah, so what we're saying is AP is equal to
What one?
AB minus
That's a good clue.
PB, isn't it? If you look at that, you think that's what I'm going to need to do. Alright? And PB is Z. So we've just got that.
And the original PB is Y.
So that's 12. The other one was AB was Y. Okay. So what was it before? 18. So I've got that is 6. So I'm thinking through my process, that's what I'm doing. Alright? So we've got now 5y goes to 4z. You notice it's as they said, it's dropping by 1. Alright? That distance. So use your method for question 4, show that AP equals BQ. And this is where you have to show that it works. You can't just say, well, if I say this is true, give a number. So how could we do this now, but not do it for one specific situation? So we would be looking at saying, well, AP is equal to, like we did before, AB minus PB. Okay? So what did we have up here? Actually, it's not PB, is it? It's, yeah, it's PB. So PB would be Y. So we've got Y take away. Is that okay?
And then you know that y equals 20 and z equals 16. So AP equals 4, because that's 20 to 16.
Okay? And we've got to show then that AP is equal to BQ. And we also know then that X is equal to,
That leads us to believe that BQ equals X. Oh, or 0. Wait, so then, yeah.
is that right?
No. Wait. I got Z equals 4X. So maybe that is right.
Yeah,
Yeah.
same thing, isn't it? This is what we did before, wasn't it? We looked at this. This is one of the earlier ones, yeah?
Yeah. This is question 5.
Yeah. Question 5. To first show that question, show that AP is B. This is where a few of you kind of lost the mark. So those of you who've got it, what did you show? How did you show it? Right. Go on then, Nick. Do you want me to rub off and start again? Tell me exactly what you did and explain, for those people that didn't quite get it, what did we write? I don't, well, I want you to explain. Go on.
It's not a good explanation. I'm just going to say that.
For those that did it right, go on, Ashley, go on, tell me what you did.
Because I did AP equals y minus z,
and then BQ equals X, and then Y minus Z equals X. And
So,
then
hang on, say it again. So then you did,
Y minus Z equals X.
so BQ equals
X.
X.
And then Y minus Z equals X. And then I found the values of X and Y, Y and Z. So Z was 4X and Y was 5X. So then it was 5X minus 4X equals
Okay,
X.
so we've got this, we've got Y is up here. So we've got Y is 5 times X, yeah, or X times 5. So Y equals 5X, Z equals 4X, yeah. So that's where you get that.
And it's 5X minus 4X.
So actually this step here kind of goes in between that point. Okay? Does that make sense?
Yes.
Ethan, you with us?
Yeah.
Yeah? So we put the 5, this is what it was looking for in the mark scheme, of knowing the 5x, 4x, y minus z. We're stating that, BQ equals x, which it does, and then we're also saying yz is equal to x because we did that, y minus z. Great.
So, we already had someone explain this.
Yes.
Okay.
Okay, so that's how you can show it without putting a specific number. Okay? And then it's the same thing again, right? But this time, we're generalizing it. So we're saying PS has been decreased by 1 unit. So, what's the difference then? Greg, you try.
Oh no, this is the one that I got. Like I didn't expand on the.
Well, go for it then.
Oh.
Now you know your mistake.
So, I started off. So PS is N, right?
So we've said PS is N. Yeah. Okay.
And N was decreased by 1 unit.
Am I doing that on the wrong diagram? That's N, so actually PS
That's
should
N minus
be
1.
N minus 1.
Yeah. So you start out. I
So
started.
we'll
out
see that, everyone that maybe didn't get to this point.
because it was decreased by 1.
Yeah. I think most of you are alright with this. Then,
So I started out with the same like basic statements that they had earlier.
yeah,
AP equals Y minus C, BQ equals X, and then I'll we want to explain it later. I first wrote N, N multiplied by X equals Y.
yeah,
And then, then that means Y equals N times X, right? That's an easy way to write it.
yeah.
And then N minus 1, all of that in brackets, times X equals Z.
So basically the same thing we did last, but using N and N minus 1. Yeah,
And then, so from this you can write Z equals N minus 1 times X. Same way last time we
Done
both
that,
wrote, yeah.
Okay. So then we're saying that
AP equals N times X
NX
minus
minus,
N minus 1 X. And then from that you write,
and this is where some people either made a mistake or didn't finish it.
Yeah, that's where I.
So we've got NX, but then if we expand this,
that's really X.
NX minus X. I've kept the brackets in because, remember, if we've got a subtract with a whole expression, you have to be very careful because it then becomes NX minus NX plus X,
Yeah.
which is
X.
X. And therefore,
B
BQ
X.
equals AP. Okay?
And then yeah, B. So would that be
Yep,
perfect?
Oh.
that's what we're looking for. So a couple of people didn't do the having it be plus X in the end. They didn't.
Yeah, I
Have to-
messed up my signs.
Yeah. having it cancel out correctly at that point.
Oh,
So you see now it's a lot easier than doing the whole Pythagoras theorem, which is good.
so I feel like from that it's pretty easy to discern that.
But you didn't, and that's the difference between a 7 and an 8. It's the
Okay.
communication of.
I don't understand what was wrong here except for the fact that I like using an example.
Well, that's what I've been telling you this whole time. Using an example is not showing that it's true for everything.
You know?
Kind of what I've been doing right from the start, of explaining that.
And one day you can.
But you can. It adds to it, doesn't it? Okay, so that kind of these ones were simple then, yeah.
If you got everything.
Yeah. So if you've done all the others, it's fine. I think most people even got these right if they didn't get the others right. So what are the answers? So -2,
AP equals x over 2,
x over 2.
and then AP equals x over n.
Is there anyone that doesn't know where that comes from now? Right. Go on then, Greg, explain.
This whole time, we have been acting as if RS is 1, the whole, like, for all the other questions, and we haven't considered that RS could be any value, right? So, since we've established earlier that AP equals x, we like read in the question before, now that this other variable has been introduced to the equation, all we have to do is think about how it affects x, and then how to counteract that. So say RS is 1, like how it's been for almost every other question, or no, never mind, forget that. Say RS is 2 instead of being 1, like how it was for every other question. Now, all of a sudden, x is twice what it would have been normally if it was 1. So to counteract that, you make it AP equals x divided by 2 instead of just AP equals x. That's it.
Anyone want to add to that? Anyone want to explain
That's
it?
probably a better way to say it.
Ashley?
Well, AP is equal to B2 of an
So, AP here is equal to BQ over RS, so we're using the ratios of similar shapes. Yeah? Ashley, go on.
And then, so that's also the scale factor of enlargement. And then, because,
You do. Tatum.
So wait, I just want to work this up here. I just like made one. So I started with just this triangle.
Yeah?
And I made this 5 and this 2.
Yeah?
And then I figured out that if you have 2, and then I used the scale factor of 4. And so I had 2, 5, and then 20, and then 8. Because you times 5 by 4.
Yeah?
And then I did the same thing down here, starting with 5 and 2. But since this is moved in 1, it's 4. Because it says up there it's moved in 1. And then that's 2 right there. And then we just end up being 8 and then 16 again. Because you times them both by 4.
Yeah?
And then it's easy when you go down because it's just AP to find like right here. You just subtract up there by here. So you just
Yeah.
subtract 20 by 16, which equals 4. And you know x equals 8, and then 8 divided by 4 equals
So you've gone about it again that route. It's again giving an example to work it out.
2. Yeah. But it's easier to work in variables.
Yes. But what you've been able to do in this sense is that one example has led you to a generalized conclusion. Right, this is where this question is a bit easier. But again, if you want your 8s, you need to do it in a kind of generalized, using algebra form. Yeah? Does that make sense? The difference between giving a number, which is absolutely fine for one sense. If you want to work out the relationship with something, put numbers in and try and find it. It's absolutely fine. But to be able to do that just by using algebra and doing it in a general sense, that is the next step above that we're trying to get to. Does that make sense to people where the difference is? And that's where you can get a lot of the right answers, but the way you went about doing it does not show the higher level of the mathematics. Does that maybe answer any questions as to why you didn't get as good as maybe someone else? Or
Yes.
yeah? Good. Any other questions or comments? No? Okay, right. Well, let's have a look at trigonometry. Tell me what you know.
Pythagoras theorem.
Okay, let me just write. Elaborate on.
You don't like SOHCAHTOA.
No, I love SOHCAHTOA.
I used to think
It sounds like an indigenous.
Right, so SOHCAHTOA, to me, I always remember SOHCAHTOA just because it sounds like Krakatoa, which at the moment is exploding in Sicily or whatever, isn't it as well? The volcano, so I don't know, that's just my link. I just remember SOHCAHTOA like that. Some people remember some old hags came and had tea one afternoon, or sailing off, whatever. Some old, yeah. You can remember, however you want it. SOHCAHTOA seems to work for most people, but what is SOHCAHTOA? What it's something, does anyone know the word for in English for something that...
Mnemonic device.
It's a mnemonic device. I don't know.
And it starts with a P though. It's like,
Yes. Yeah, you should have put your hand up and waited. Right, okay. So we're in for what it means.
if you have two sides of a triangle, then you can use SOHCAHTOA to find the side.
I'd be more specific. What does SOHCAHTOA stand for? Nicholas trying to sing out loud on a video that your parents might watch, disrupting my lesson.
I was going to ask.
Tatum?
Sine, opposite, hypotenuse, cosine, adjacent.
Be more specific.
Sine equal opposite.
Be more specific. Be more specific.
Sine degrees equals
What?
sine the number of the degrees.
So you're missing something here. You're definitely missing something. Yeah.
the numerical value of
No, you
sine.
don't need to be over the top. right?
Bracket.
Sine of the angle that you're trying to find equals opposite length, the length opposite to it.
Yeah, you don't need to be any more
Adjacent.
specific now. You got the bit I wanted, which was sine of the angle
That's what I was trying to say.
Yeah.
Equals to sine opposite of hypotenuse.
is equal to opposite divided by, which is nice for our what we've just done. Opposite divided by hypotenuse is a what?
Fraction.
It is a fraction. It is an expression. It is also a
Formula.
could be, but that bit opposite over hypotenuse is a fraction. It's a division, also called a ratio. Yeah. It is a ratio. So what we are looking at is we are looking at the trigonometric ratios. The people that discovered these looked at the ratios of sides. So you've just been doing that exam paper on right angle triangles and looking at different ratios. And trigonometry is about, well, can we find anything about those ratios? And the thing is, if I find the ratio of the opposite and the hypotenuse of a triangle, okay, of a right angle triangle, right, given a certain angle in that triangle, I will always get the same number. So if I have a right angle triangle and I know what the angle is, let's say I choose this one down there, right? How many triangles can I have with that angle, whatever it is, let's say it's 42 degrees. How many triangles are there?
An infinity amount.
An infinite number, yeah. Because I could say, well, I'll make it here. I could make it there. Just like you've just been doing on that paper, we make the triangle bigger, smaller, we extend it. So I've got a small triangle or I've got the bigger triangle. Now, all I know is that if I take the ratio, so if I start at 1 point, right, sorry, I can't really see. If I start at 1 point and go to this point, these 3 points of the triangle, if I look at the hypotenuse and I look at the opposite side, the ratio of those two sides will always be the same amount. So even if I extend the hypotenuse, which then makes the opposite side bigger, that ratio is still the same. It's just a number. Therefore, the sine of the angle is that number. That's what I try and get across to people when we do it. Sine of the angle is just a number. All right? And we can use that number. So what are the other ratios then? Cosine of the angle is equal to the adjacent side over the hypotenuse.
Yeah.
And the final ratio is
Opposite.
tangent of the angle is... Now, if you were really into this, you'd ask a question.
Mm.
You're really thinking.
Yeah.
You'd
How do you know which one is adjacent?
No, I think we know that.
Why do you have
Well, that's just because there's 3 sides, and I need to use 3 sides.
Is there a ratio for like hypotenuse over the opposite side?
Yeah, exactly. Why are the ratios that way round?
Because it works the same other way around. Well, no, it doesn't. It doesn't matter because it's.
But, well, that's the thing, isn't it? Sine of the angle is the ratio opposite divided by hypotenuse. Someone could have just done it the other way around and called that sine. They just didn't. So, do I need another set? Do I need to say, I don't know, splodging of the angle is hypotenuse over opposite? Do I need to do it the other way around? No, I don't. However, if I did hypotenuse over opposite, what would it be called? It's not the inverse. No, the inverse means something else.
There is no name for it.
There is.
It's just sine -1.
Oh, sine is power negative one.
No, it's not. That's how I find the angle. So what would anyone know what it would be called?
Sine's going backwards.
If I did hypotenuse over opposite instead? It would actually be 1 over sine theta, which has a name.
Reciprocal time.
It's a different thing. It's useful and it's used in higher level maths. I'm going to ask you, because you're all interested in this, I'm going to ask you to go away and see whether you just find do you get the 1 over sine? Because if I flip the fraction the other way, flip both of them. So this would be like sine theta over 1. If I flip 1 upside down, I flip the other one. This would be cosine theta over 1, tangent theta. What would it be if you did it the other way round? All right. And why didn't we do it that way round? Well, someone just decided they were going to do it opposite over hypotenuse. There's no other reason. We only need those 3 because that gives us all the information we need to work out everything else. All right? You've used these before, right? You know how to solve. All right, so for instance, if I said to you, here is a triangle, it's a right angle triangle. This is theta, and this is 7, and this is 15, and I wanted to know what the angle is. You could all tell me how to do that. It's going to be tangent, isn't it? So I would write down the tangent of theta is equal to...
Sine too. It is
15 over 7? Can't be sine, why not?
It's sine It's
Actually, I
inverse
could do sine eventually if I was Kieran, because what I would do to solve the simple one is do Pythagoras' theorem first, work out the hypotenuse, then do, which is absolutely fine, but doing more work than I need. People do that, by the way. I've seen in exams, they work out the hypotenuse using Pythagoras' theorem, and then they can use whichever one they like. We can just use tan. How do I go from this, by the way, to the angle? Everyone paying attention to it? How do I go from that tan theta equals to the angle?
7, 10, 15,
No.
or 15, 10, 7.
So inverse that.
This is where I do the inverse tan. So this is where we have found a little weakness that we need to work through. So we'll probably do, next lesson we'll start making sure you can do all these calculations before we move on to 3D stuff and all that.
3D?
Whoa!
Wow, that's way too fancy.
Pardon?
Oh, no.
But I, go on, sorry.
Sorry, that project would be 25
Would it? Why?
Well, I just sometimes
7 squared plus 15 squared equals c squared. So that's 49 plus 225, which would be 274. Square root of 274.
16.5.
16 point,
Yeah, no, I did that.
not quite. Alright, so just one thing then. We'll get on, that's a good starting point. We'll make sure you can do all those calculations. We will be moving on to 3D. But can you, because you're all interested, I didn't say stand up. I didn't say stand up. Because you're all interested, could you have a look, just quickly, won't take you more than 2 minutes, get on the internet. What does 1 over sine, 1 over cosine, 1 over tangent, how is it represented? Don't guess, find it. You'll find it like that. Okay.
Like in real world?
What would I do if I wanted to do it in maths? Has it got a different name? All right. Yes, it has, by the way. Keep your exam papers there for you. I don't want them. Okay.